So this is problem one in the homework. All right. So what you want to do is first isolate cosine. So subtract the one, divide by two. Now cosine is by itself. So at this point we could use, I don't know if we've talked about that yet. Can't remember. Let me see. Yeah, we have talked about inverses, right? Do y'all remember? So you could apply them here. But anyway, since it's a simple value, we know when cosine is equal to negative half, right? Which angles would this be true? Should print this out sometime. Can y'all see the circle? Let's see. Oops. So they said radians, even though 120 looks correct. What is that in radians? Uh, Cosine value negative half at 2/3 pi, right? Or else, remember it said between 0 and 2 pi. So you only go around the circle once is what that means. So 2/3 pi, or 2 pi thirds. And where else do we have a negative half for for the x value? Yeah, 4 pi thirds, which is 240. Yeah. So let's write those answers down. The solution is simply 2 pi thirds and 4 pi thirds. And that's it. So when it's a simple number and it's on the circle, it's not too bad, right? Is there any questions on the algebra part or why these were chosen? Oh, let me switch back. Sorry. Dang it. Too many cameras. Okay. Alrighty. Uh, any questions on this algebra part or why these were chosen? You guys okay?
So it's for every single time that cosine is negative one half, and then on the unit circle, we would go to where x is negative one half, and that would give us our two answers.
Yeah, since it's a value on the circle, we can just pick them off. Just don't go further than one revolution, right? 0 to 2 pi.
Right. But like, say for example, that cosine was one, but because the way that the interval notation is, we wouldn't include zero or sorry, we would include zero, but we wouldn't include 2 pi.
Right, because that's technically the same number, but you went all the way around, so you would not include it.
Okay, because there's the parentheses and not the bracket next to the 2 pi.
Exactly. Yeah.
Okay.
hmm Okay. So now let's do another one where they don't limit you to one revolution or one period. This is number 83, I think. Double check, actually. Yeah. Find all solutions for, so sine theta equal to negative 1/2. So very similar to the last one. So look at the circle. Let me put it back up again. Can you guys see it? So since they don't have a limit of 0 to pi, then that means you have to include every revolution over and over again. All of them. So negative half for sine is going to be here. And there, right? And then it just keeps repeating over and over again. So what we want to do is say, you know what? The answer is going to be this solution or this value plus 2k pi, where k is any number. Because if I add 2 pi, then you guys remember it's going to go all the way around and land again. If I subtract 2 pi, go the other way, land there. If I add 4 pi, just be 4 circles, and then back in the same spot. Or if I subtract 4 pi. So as long as it's a multiple of 2 pi, then we have our answer. Okay, does that make sense? Maybe you could. I mean, it is related to the period.
Yeah, so we would use the periodic identities, and in this case, our theta would be either of those plus the 2k pi or whatever.
Yeah. So
Okay,
those two solutions, just tack on 2k pi to each of those answers. So
okay.
let me switch back. But sometimes they might land every other pi or every pi instead. So you just have to be careful. But if you can't include both at once, where was it? I forgot. Here. There's no way I can make it land there and then there with one formula. So you got to do two separate answers. Okay, let me go back. Cycle through my 30 cameras here. Okay. So anyway, so from the circle, we know that the answer is equal to 7 pi over 6 and 11 pi over 6, right? That's what we said. So just all you got to do is add 2 pi k, 2 pi k, where k is an integer. So if k is 0, then I get this answer. If k is 1, then I start here and then go around one circle. If k is 2, then I start there and go 2 circles around. Same thing here. So k can be any integer, positive or negative, right? So integer means. Uh, so just find the answer like we did in the last example, up here, but tack this piece on by looking at your circle and seeing, okay, well, I'm going to land on an infinite number of times if there's no limit like this. So how do I encompass all of the answers? So that's all you got to do. Just tack this piece on.
And the where k is an integer, the annotation for that is the k, the weird fork symbol, and then the I think zeta, maybe that's what it is. That
Yeah,
pretty little z.
in math symbols, it's K, an actual English K, and then a lowercase epsilon, which means element of, and then this fancy Z, which I don't know if I can draw, but maybe something like that. I was just gonna put a normal Z, but basically what that means is the set of all integers. So it's just the symbol for integers. Okay. But I put it in English because not everyone has gone over the all the math symbols, but K is an element of the integers. In other words, K is an integer. Same thing. Yes, Alejandro?
Oh, that there's just the clappy symbol.
Oh, I couldn't tell. I was like, is that a wave
A
or
hand raised, yeah.
my bad.
Would we
Okay.
use the or? Um, would we use or here because they're
Oh, you mean
distinct sets?
to write this set? Yeah,
Correct.
I mean you should. It's either or both. But yeah, I think in the homework they might put an or in there for you. I don't remember how they write it. But there's two infinite sets of answers, right? This one or this one. Because they're periodic. Okay. Let's do tangent. Let's see if there's a good one in here. Yeah, this one seems fine. What number is this? One, two, three, four. Yeah, this is four. When you get to higher level math, they use more and more of these symbols. I remember towards the end, we ran out of Greek letters. We started using like Hebrew letters, and it got kind of weird. But I'm sure you're not going to do that. You're not. If it's only for math majors, really. You shouldn't see the Hebrew unless you're talking about levels of infinity, like different levels. This is usually when it comes up.
For problem three,
Mhm.
that 2 pi k, would that ever change for some reason, or is it gonna
It
be
will change depending on like this next one here. Let me show you.
okay, cool.
Uh, it depends where it's at and how you want it to land on it. Because you can see going around and around, you're like, well, if the answers are on two opposite sides, then you can land on the next one by adding pi and then pi again. So when that happens, you would add pi k instead of 2 pi k.
Okay,
Find all
thank
solutions for tangent theta equal to 0. All right. So where is tangent equal to 0? Remember, this is the same as saying, right? So a better question is when is sine 0 on your circle? That's the only way this would be equal to 0, is that when the numerator is 0. Let's see. Sine 0 at 0 and pi, right? 0 and pi. So the solution is only 0 when sine theta is equal to 0. There's another math symbol. Therefore, theta is equal to 0 and pi. But since it said all, I'm going to have to add some sort of k part. Okay. So we'll call this pi. Actually, we could do this. Hold on a second. Let me get the circle on so you can see better. Okay. So sine 0 here and here. And then I'm going to keep repeating forever, right? As long as I keep doing revolutions. But you can see that if I add pi to 0, I'll end over here. If I add another pi, I'm back to the other one. So I don't need to do two separate ones with 2k pi. Just combine it into a single one and say k pi. You see what I mean? Because if my answer is 0 plus k pi, when k is 0, I'm right here, right? When k is 1, I would be at 0 plus pi, which is pi. When k is 2, I'm back over here at 2 pi. K is 3, I'm back over there. So any multiple of pi will get me to one of the answers. So really there's only one solution that can kind of cover both parts. So whenever you have an answer that's on two separate parts of the circle, two opposite sides, you can just add this, you can combine them into one. Okay. Yeah, pretty much like a half revolution. It's kind of like when you're coding and you want to simplify the formula, right? Instead of having two separate formulas or separate loops, you just have one. That loop will do both. Okay. Let me go back to the paper. Yeah. So
I have one question.
oh yeah, go ahead.
What are those three dots meant to be?
Oh, so this is another math symbol. It means therefore.
Oh, okay. Thank you, sir.
Hmm. Yeah, they don't come up. It doesn't come out much unless you read a lot of math books. Maybe some science books too, like random science books. Okay. So 0 plus k pi is really just k pi. So as long as that's there, then I take care of both of these parts. So this is all solutions, and this is just two of them, right?
Why wouldn't it be pi plus k pi?
You could technically that would be acceptable because if you had pi plus k pi, well, actually, Yeah, it would cover it because if k is all integers, -1 will get me the 0, so I should get them all. Yeah, both are mathematically correct, but they are the same. So you wouldn't write both. You pick one, right?
Okie dokie.
Another question.
Mm-hmm.
It says it would only be zero if it was sine equals zero, but what if it was cos instead that equals zero?
Cosine equals 0, then it would be pi over 2 plus k pi.
See.
Okay. Any other questions on 4? Okay, 1 second. You try to find another one. It's not too crazy. This next one looks kind of ridiculous. Okay, I found it. It's fine from the homework. Find all solutions of the equation in the interval 0 to 2 pi. And then we're going to have, so everything's in this one period. So it's not going to be infinite. So that's the hint. When you see that little symbol here, 0 to 2 pi, this little interval, they're telling you it's going to be just a couple of answers. You don't have to add the k pi. Okay. Now, 1 second. Sorry. Getting spammed by messages. Alrighty. Cosecant plus 2 times secant minus 1/2 equals 0. So what would y'all do for this one? Or how would you approach it?
Will we treat them as like separate equations the same way when we deal with factoring or
Yeah, pretty much.
polynomials?
Yeah, treat it exactly the same. So basically you're solving two separate ones at the same time. Alrighty. So solve for the trig function. Subtract the 2, add the 1/2. Now use your circle. What is secant again?
Uh, the reciprocal of cosine, I think.
Yeah, this is
Yeah.
technically this, right?
Yeah, that one.
And this one would be. Now, if I
Yeah.
were to take the reciprocal of both sides, which I can, do you see an issue? Is cosine ever 2?
Not in the interval that we're looking at.
Yeah, it's never going to happen. It's outside the range, right? It's between -1 and 1. So this has no solution. In other words, secant is never going to be a half, which is the same as saying cosine is never going to be 2. So we really only have one to look at. So which angles is sine equal to -1/2 on the circle?
7 pi/6 and 11 pi/6.
Yeah, that's it. Since it's only one interval, we don't add the 2k pi. We only do that if it says final solutions and there's no restriction. That makes sense? Oh, right here. So from this step to the next step, just subtract 2 on both sides because you always want to isolate the trig function. That's how I get to here, but I don't have all the cosecant angles memorized, so I changed it to sine, and we know what this is. That was the goal. And same thing here. I don't know what secant half is, but if I change it to cosine, it was pretty clear there's no answer. Are there any other questions? All right, let's do a different one. This is number 6. So find all the solutions of the equation in the interval 0 to 2 pi. So secant squared equal to -4 equal to 0. So first step, isolate your secant by adding the 4 over. Square root both sides. And remember, you have to tack on that plus or minus somewhere. So I'm going to put it here. So now I have two separate 2's, positive and negative. And change it back to cosine. And take the reciprocal. Where is cosine equal to positive or negative half? We're gonna have four, probably gonna have four answers, I think.
I have a question.
Mm-hmm.
How does it change to half?
Basically, the rule I'm not showing is this. So if you had like x equal to 2, I could technically take the reciprocal of both sides and flip them over. So what I did is, well, I want cosine on top, so I flipped both of them over. Got to here. You could do a bunch of algebra to get to here anyway, instead of doing this, like a weird cross multiplication if you really wanted to, but I think this is much shorter. But does that make sense?
Yes, sir. Makes sense.
But yeah,
Thank
so
you.
I'll make a little note for you in case you forget later. Here to here. We took the reciprocal of both sides. Ah, shoot. Anyway, so what's the answer?
Where around the unit circle we find a half as the x value, whether that's negative or positive. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3.
4 pi and 5 pi?
Yeah, bunch of pi's over 3.
Yeah, it looks right. So anywhere we have a half or a negative half, this is where these answers came from. Any questions on number 6? Okay, let's move on. Number 8. Find all solutions of the equation on this interval. So what does that look like to you?
Like a quadratic equation, like a trinomial, I think.
Yeah, it's exactly what it is. It's just instead of a variable as a trig functions. So what we can do to make it more obvious, in case you don't see it, is let W equal secant. Can you solve this quadratic? It does factor pretty. What are the factors going to be?
To a negative one.
Yeah, plus 2 minus 1. So that means that W plus 2 is equal to 0 and W minus 1 is equal to 0. W equals negative 2. W equals 1. W was made up. So let's go back to secant. We're solving for X, not W. I say we change it to cosine again. It's kind of weird. I don't like solving it straight up. Unless you want to, you can. The reciprocal of 1 is still 1, so that didn't really matter. But it looks better, right? What are the solutions? When is cosine equal to negative half and 1?
For cos x, it's 2 square over 3 and 4 square over 3.
No, and then like at which angle X am I going to get a negative half?
I think it means 2 pi over 3 and 4 pi over
Oh,
3.
I
Yeah,
see.
it's 2 pi, my bad. My bad.
Oh, I get you now. My bad.
I mistook
It,
like square for pi or and all that.
That's
It
okay.
does look like a little square.
Oh, this guy.
Yeah, it looks like a box.
I suppose so. When is cosine 0? It's an easy one, right?
2 pi.
True, but they said don't go up to 2 pi, so we can only use 0 because it had parentheses, right?
So it's up
Uh,
to, but not including.
Yeah, stop right before. Any questions on 8? Is the old school algebra okay? The dummy variable okay? And the unit circle part okay?
I like switching out for the W because it makes it easier to solve.
Yeah, it makes more sense. We're talking about this part, Jennifer, here. Oh,
Yeah, when we say that W equals secant X, it just makes it easier to solve, and then we plug it back in at the end when we find out what W equals.
yeah, it's not too bad. Uh, as far as talking about this, Jennifer, you said this one here. Yeah, okay. Yeah, we're just isolating W. So once you do the factorization, right? Factoring the quadratic, set each one to 0, just like we did back in the day. Solve for W, so you'd have to add 1 to both sides, right? That would get me to here. Minus 2 gets me to there. Do you remember? Okay. Then any other questions? Oh, excuse me. Putting myself to sleep. Okay. There's so many types of problems here. Hmm.
Correct me if I'm mistaken, but it seems like it's a good idea to just convert any equation you have into cosine and as something that you do first because of like a lot of the identities and stuff that we learned in unit 2 here seems to be heavily weighted towards cosine for some reason.
Yeah, I mean, if you see any reciprocals, for sure change it to cosine or sine. Um,
Okay.
but yeah, I mean, it might be just random chance, like you see cosine more often, but I definitely
Have an
suggest.
angel number situation.
Yeah, I think so.
All right.
But but if you do have a reciprocal, no matter if it's secant, cosecant, cotangent, just you're probably gonna want to switch it up
Yeah, that's
because
fair.
like I was saying earlier, like I don't have this memorized. Like when is secant equal -2? I'm like I don't know. Like I know where cosine's at, so that's
yeah,
what
I
I
think just
recommend.
so far we've been having a lot of secant trig identities.
Yeah, I'm picking them at random, but I guess that's what we got. Sorry, it's not intentional. I'm skipping questions that are similar. Maybe the other ones are assigned. Maybe we shall see. I guess you will see when you do the homework. Okay. 8. So we're on 8. This one has both. So when you look at this, what's your first instinct or approach you want to consider?
Run and hide in the little corner. Um, all jokes aside, maybe square it so that
Yeah.
yeah, because it's looking scary right now.
Yeah, it looks gross. So let's square it. So the reason there's so many different types of trigonometric equations is because there's a lot of different types of algebra equations. So it's all the same, but instead of solving for x like we did a bunch in high school, middle school, and college algebra, we're solving for the trig functions. So it's slightly more complicated. But it's really the same scenarios, right? We've dealt with square root problems before, and whenever you had this isolated, the rule was square both sides. And whenever you did that, you would sometimes introduce fake answers. I think the book calls it erroneous solutions because it wasn't originally squared, but you have to square to solve it. So you introduce more complexity that wasn't there. So you got to check all your solutions. Okay. Now that we're here, no more radicals. What do y'all think? What should we do next?
Use a Pythagorean identity for the cosine squared x.
Yeah. Whenever you're solving equations, you want everything in terms of the same variable, or in this case, the same trig function. So yeah, use Pythagorean here since you see the square. Your instinct should tell you, oh, there's a square there, then I can do Pythagorean, right? So I can switch this guy into 1 minus sine squared. Let me add some instructions. Okay. So now everything's in terms of sine. So let's move everything over, see what happens. Subtracting the sine, subtracting the 1. Those ones will cancel. But let's show some steps here. To subtract 1, subtract sine. So I'm subtracting both of these on both sides. So, or if you, I like to think of it as I'm just going to move it to the opposite side and change the sign, right? Just move the 1 there, move the sign. But it's because you're subtracting. These ones will cancel, so now we're left with negative sine squared minus sine x equal to 0. Okay, so is the algebra okay so far? Okay. Alrighty. So what would y'all do next? We're almost done, kind of.
Power reducing formula?
Hmm. You could, but you would
Or
make this question
factor
harder.
out the sine x. So like kind of like how we did that one problem where we said like W was sine x
Yeah, just treat them
and
as some
like factor it
variables.
out.
Yeah, like if you had this is what you're thinking, right?
Yeah.
You would factor in order to solve, right? So it's the same thing. I don't know what happens to that W, but factor sine, and we get to here. I factored the negative at the same time, so that switched the signs. Okay. Oh, which Pythagorean? I didn't see that. The OG sine squared plus cosine squared equals to 1. If you solve for cosine, right, you get this guy. Then give you like 9 of them. If you solve for all of them, I made you a list. And um, it's also in the formula sheet, but they're not all solved. But you can kind of see it. But anyway, let's keep going here. And divide that negative out, it doesn't really matter. Solve for sine by subtracting the 1 on both sides. Now, what are my solutions? When is sine 0? When is sine negative 1? What the heck?
Sine zero, it's for sine zero, it's 0 and pi, right?
Yeah, sine 0 is going to be 0 and 2 pi, but we can't include 2 pi. Um, sorry, 0 and pi. Is that what you said?
Yeah, yes, sir.
Yeah, that's right. Um, when is sine negative 1?
3 pi over 2.
No, that's it. Any questions on the algebra or identities?
Do we plug it in because we added or introduced complexity at the very beginning to check our answer?
Yeah, we still have to test. Like, are these actually answers to the original? These are solutions to the new one, but are they to the old one? So let's test. Is cosine 0 equal to the square root of 1 plus sine 0? Whoops. That'll be 1 equal to 1 plus 0. 1 equals 1. So we're good for that one. Is cosine pi, you can already see this one's not going to work. This will be negative 1 equal to 1. Sine of pi is 0. Square root of 1. 0, 1 plus 0 is 1. Square root of 1 is 1. These are not equal. Cosine of 3 pi over 2 is that equal to 1 plus sine of 3 pi over 2? This will be 0. This will be 1 minus 1. So yeah, we're good. So we only have two answers that actually work. Anytime you square both sides, you should check. Sine of 3 pi over 2 is negative 1 on the circle. I'm talking about this one? Yeah, so on the circle, this will be negative 1. 1 minus 1 is 0, and we're good. We have equality. Anytime it's not equal, it's not a solution. So you throw that one out.
Can we put a weird slash through the -1 to 1? Okay,
Yeah, it's totally fine.
okay.
I felt it too. It's like it's just
Ugh.
wrong.
No, it's just gonna mess up my brain. I have dyslexia already.
Okay. Any other questions on 9? See what 10's about. 10 is similar, just a little harder. Let's pick something else. 11. No, it's different. Let's do that. Let's do this one. So solve for all solutions on the interval 0 to 2 pi. So how would y'all approach this one?
We could make it weird with the double angle identities.
Yeah, I think that might be our only choice because they can't do any factoring because they're not the same. We have three different formulas for cosine double angle. Um, The one I'm going to choose is the one that has cosine in it, so that way we can factor this guy. I think there's, yeah, this will work. Yeah, that's the one. The first one wouldn't be helpful because it would introduce a sine. If we were to choose that cosine squared minus sine squared, we'd have to use Pythagorean to change that other sign. And then we would be good. We would end up at the same place, but picking this one here, it saves us some steps. All right, so I'm going to replace this guy. 2 cosine squared theta minus 1 minus cosine. And then solve for cosine. I can already tell these ones are going to cancel, right? Factor your cosine. And we're almost there. Now, since it's fact equal to 0, we can do this. But you can only do this if it's equal to 0, right? Isolate your trig function. Add your 1 over, divide by 2. We get to here. So when is cosine 0 and when is cosine a half? For sure 0 or 0. No, that's wrong. Where else?
5 pi over 3.
5 pi over 3. Oops, I don't like how that looks.
And pi over 3.
And so we should have 4. Any questions on the algebra or the identity? Okay, so in the beginning, we had a double angle, which we couldn't really deal with, so we substituted with one of the double angle formulas for cosine. Once we got there, we set it to 0 by adding 1 to both sides. Factored the cosine, set each factor to 0, and then solved. You guys cool on 11. All right, let's move on then. One second. Hmm. This is a good one. 13. Find all solutions. Sine of 4x plus 1 equals to 0. So whenever you have like a big angle like this, like 2, 4, whatever, it's gonna mess up your period. Um, Let me see if I can get a picture for you. Here it is. Just real quick. This is what the original sign looks like. Now, if you were to add 4x, you're basically speeding it up. So the period becomes a lot shorter. So this one is repeating itself every 2 pi. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Then it starts over. Okay. This guy seems to be repeating itself 4 times quicker. So they'll go up, down, and then repeats itself at 1/4 the period. versus the original. Okay. So that means if we were to close it off in one period, like or sorry, from 0 to 2 pi, it's gonna get those answers multiple times, not just twice. Like let's say it was sine 4x equal to a half, like we've been doing, or something like that. It would hit it a few times, not just twice, because the period is going up and down, up and down. It's going to hit the half quite a few times because um, because 2 pi is over here. Y equals to 0.5 is there. Let me get let's talk about the red one first, right? We know in the unit circle that pi over 6, 5 pi over 6 in one period are both at 1/2. If you look at your circle, I asked you when is sine equal to half, you would find these two, right? Now, if I were to speed it up and increase the period, now it's happening a lot of times before I even hit 2 pi. You see what I mean? So instead of just 2, I have what? 8? So it is going to quadruple the solutions. But thankfully, this question said find all solutions and didn't restrict it to a period. Because if it did, then I'd have to find all those 8, which would be annoying. And I would prefer it's not a 4. I'd rather have like a 2 or something, you know, because then we'd have just double instead of quadruple. And it would be probably 2 pages of nonsense. But anyway, uh, since they said all solutions and it did not say anything about 0 to 2 pi, we just got to tack on the 2k pi and we're good. Nothing crazy. So let's start it. Okay. Hmm. So sine 4x equals to -1. So let's pretend it's a normal sine. When is theta going to equal -1? I mean, sine theta. When does this happen?
At 3 pi over 2?
Yeah, so our answer would be if it wasn't a 4x, if it was a simple theta, we would say 3 pi over 2 plus 2k pi, where k is an integer. But that's not the case. So what we really have, right, is this. So solve for x, divide by 4 everywhere. Oops. That'll give us x equal to 3 pi over 8 plus k pi over 2. There's a dummy variable to make it simple. Bring back 4x and solve. So now we have the actual solution set. So 3 pi 8s every pi over 2, k pi over 2. We'll get another answer. Thankfully, we don't have to find the specific ones and we can just stop there. Is there any questions on what we did? Or the algebra? Not too bad.
So you just replace theta with 4x and then, plugged it in normally
Mhm.
for a typical answer and then made it all equal 4x eventually and then just algebraically solved for x by itself instead of x or 4x or whatever.
Yeah, because I figured we've been doing this over and over again. So
Yeah,
finding this is a lot easier.
yeah.
So if we bring it back to 4x, it's just one extra step. If we
Okie
think of
dokie.
it that way, it's not too bad, I think. Does that make sense? Or
Yeah, we solved by substitution, kind of like when we did with the W thing.
yeah, pretty much. I think substitution makes it uh, easy to grasp.
And easier to look at.
True. Yeah, it does sometimes make it pretty. It's very true. All right, we'll do one last one, and it is going to be the one that I didn't want to do, but oh well. It's going to be a double angle, so it's only going to be 4 answers. 14. And I'll do the review and send that to y'all later because that's going to take some time. That's it. This week's goal is finish all the homework, start reviewing, and take the test when you can. I don't know what date I put. I forget. I'll check later.
Hello?
Mhm. Okay, so we're going to do the same thing we did earlier, or the last example. The only thing is, once we get that piece, we're going to have to find every specific answer by cycling through. All right, so here we go. Subtract your square root. Divide by 2. Now we're here. Once you're there, let theta equal 2x. So what is this the solution set for sine theta? What theta gives me root 3 over 2? Negative.
4 pi over 3.
4 pi. And what else? So theta,
5 pi
put,
over 3.
we'll put it over here. Theta is equal to 2 pi over 3 and 5 pi 6. So or what was it? 5 pi thirds? What did y'all say? Yeah,
Yeah, 5 pi over 3.
yeah, okay. Be 4 pi, right?
Yeah.
Okay. It's an ugly 4. Alrighty. All right, so theta is not what we're solving for. So what we're going to do is have two sets. 2x is equal to 4 pi thirds and or 2x is equal to 5 pi thirds. Divide by 2 on both sides and you get 2 pi thirds. 5 pi 6. So then we tack on our, forgot to add that, my bad. I skipped a minor step. I divided each one by 2, which gave me these two. Divided both of these by 2, which gave me this. Okay. Is that okay? Y'all still with me?
Question.
Yeah. Yeah.
Uh, for uh, for four, sorry for 4 pi over 3. How come the 4 changes to a 2? Meanwhile, for 5 pi over 3, the only the bottom number changes. Like 3 changes to a 6. You know what I'm saying? Like, what's the difference?
No, I got you here.
Oh, because it was reduced.
Pretty much. I mean, you could think of it either as it turns into a 6 and then reduces, right? Or you can think of it as 4 divided by 2, which is a 2. Both are the same. Would you like me to show you the details, or does that make sense?
Can you show me the details, please?
Yeah, no big deal.
Yeah, because it would have been 4 over 6, which reduces to 2 over 3.
So you would divide everything by 2. So we could say this is 4 pi 6, and then these reduce to 2 pi thirds. Does that make sense? Or
Yes, sir.
no? Okay. One moment. Sorry. Alrighty. So that's the general solution for all solutions, but that's not what they want. This will help me find what they want. I need to find all of them from 0 to 2 pi. So I'm going to choose k equal to 0, 1, 0 and 1, k equal to 0 and 1. That'll get me the solution that I need by adding it to this. If I choose k equal to 2 pi, then that's too big. So I'll go beyond this, right? So I'm going to choose k equal to 0 and 1. So I'm going to have four answers. This is the best way to find it. So let k equal 0. That'll be the first solution. Let's call it x1, I guess. Let k equal 1. That'll be x2, so that'll be 2 pi thirds. Sorry, I'm not on the screen there. Plus 1 pi. Add your fractions, that'll be 3 over 3. Be 5 pi thirds. So there's my x2. So I got one answer, one answer. Now do it again for these here. Let k equals 0. That's the first one. Call it kx3, I guess. Oops, write the note. X4 will be 5 pi 6 plus a single pi, which will be 5 pi 6 plus 6 pi over 6, which is 11 pi 6. You see what I mean by if it's a quadruple angle, we'd have to do this 4 times for each set. And if I were to let k equal 2, that'd be too much. That would be beyond the 2 pi.
I'm a little confused um, how, or I guess why we decided to add 2k pi.
I added that to help you find x1 through x4. So without this guide, it's not very easy to find it. So what I did was find the solutions, right, in general for all solutions. Then I went back and answered their question for the solutions on 0 to 2 pi. So now I'm like, I don't want to get an infinite number. I just want to get the ones that are inside 0 and 2 pi. So that's what these are. So let me show you the graph. One second. Okay, there it is. Okay, so we have a double. So that green line is the end of the period, 2 pi. They want all the answers from 0 to 2 pi. The ones that they want are square root 3 over 2. So how many times does sine 2x intersect with that number? These would be all the solutions that belong to sine 2x equal to square root 3 over 2. So how do I find them on paper? Well, if I know it's every, what do we say? 2 pi thirds plus k pi, then I just gotta add 1 pi or 0 pi and 1 pi to get the first one and the second. And then go to the other set, 5 pi 6, add 0 pi and 1 pi, get the other two. So that 0.866 is square root 3 over 2, by the way. So what I recommend whenever you have a double angle equal to some number is solve for all the answers like we did on 13, and then plug in K0, K1. If it's triple angle, then you do 0, 1, and 2. So you would have 3 for each one.
I thought y equals negative square root 3 over 2.
Oh, it's negative, right?
I think so.
Oh yeah, let's put the so it'd just be down here. My bad. But same idea. Does that make sense?
Yeah, I guess so. Instead of having to write all those intervals, I guess I guess we're taking advantage of that K formula or
Yeah, because the double on the sign is basically making it end twice. It's basically finishing this period twice as fast. So originally, right, the original only has two on the unit circle. You would just go to the unit circle and say, well, there's my two answers, right? On if sine x was equal to negative root 3 over 2. But since it's not a normal sign, then it's gonna repeat itself another time. Hence why we have four of them instead of just two here, because it's repeating itself twice within that 0 to 2 pi. Does that help?
so when we say 5 pi over 3 and 11 pi over 6, that covers everything in between, I guess. Is that
Yeah,
what that's saying?
yeah, the 2 pi thirds and 5 pi 6 plus k pi is all these solutions, but they only want the ones before 2 pi. Because if I leave it that way, it's gonna keep going forever, right?
Yeah.
We don't want an infinite number. They want just the 4 before.
Okay.
So treat it as if it were an infinite type where you're finding all of them in general, and then just plug in K0, K1, and you'll get the specific answers, and you'll be good. Any questions on this? Alrighty, well, we'll stop here, and I'll try to get that review to you as soon as possible. Need to take rolls. Okay, is this the right one? No, that's not it. Okay, Alejandro,
Here.
Nestor, Amaya, not here. Elijah Brooks, not here. Ana Castillo,
Here.
Wendy Cuellar,
Here.
Anita Delgado, not here. Ruben Garcia,
Here.
Hakeem Hassan, no, not here. Alyssa Arevia, not here. Adam Hernandez, not here. Christy Ho,
Here.
Nolan Lopez, okay, not here. Sawyer Miller,
Here.
Luis Bas,
Here.
Madeline Pena, okay, not here. Alexis Riojas, not here. Alicia Salinas, okay, not here. Raul San Miguel, okay, not here. Alfred Serna, okay, nope. Matthew Vigil
Here. Here.
and Saida Zaidi,
Here.
okay. Right, if I made a mistake, let me know. If not, I'll see you next time. I'll try to send the review as soon as possible. If you have any questions, let me know.
On the last problem, we plug in for K up until we exceed the range, and that's how we know what
Mhm.
X is. Okay.
Right, right, because you can see what happens if you let K be 2. That you would be adding 2 pi to some number, and that's obviously too far, right?
Yeah.
So you can't hit 2. It's like a rule of thumb is if you have a double angle, then K will be 0 and 1. If you have a triple angle, then K will be 0, 1, 2. And if you forget, you'll see it as soon as you go beyond 2 pi.
Okay.
So I guess whenever we see that interval notation 0 and 2 pi, it's probably safe to say it's always going to be 0 and 1.
The 0 and 2 pi is going to tell you, it's going to force you to find those specific answers. If it doesn't have the 0 to 2 pi, then you can just leave it as 2 pi thirds plus k pi and move on. Like on the last one, yeah, let me put the screen back on. So I'm a little distracted. Just realized I lost my backpack. Everything's in there. Okay. On this guy, it was a quadruple, which would have sucked if I had to find them all. But thankfully, it didn't say 0 to 2 pi. So I just found the general case and we were done. On this one, very similar to this example, it did say 0 to 2 pi, but luckily it's a double, so there won't be too many. But I will have to do the k equals 0 and 1 once I get to after this step. So treat it as if they didn't say 0 to pi, but then add an additional step here. That's that's how I think of it. Think of this problem. Excuse me. Does that make sense?
Got it. The last question we did was 14 or 15?
14. Reduce the back. You have any other questions? I'm gonna stop recording here.